This tutorial illustrates independent samples t-test in SPSS. Here is the data from a study. I have two groups, a control group and a treatment group. Students in the treatment group complete a test with background music, while the control group students complete the same test without background music. And I want to find out if music has an effect on their test performance. I'm going to copy the data onto SPSS. Since these are independent groups, I'm going to get the data, move the data here, move this group here. So I'm going to create two variables in SPSS. One is one variable that records the scores, another variable that will be the grouping variable to tell which student is from control group and which is from the treatment group. I'm also going to code my control group with zeros. So copy this, and I have 12 students in the control. Paste here. I didn't work. Let's copy again. And the ones are my treatment group. Copy this and paste here. So I have two groups, zeros and ones. And I'm going to give the variable a heading, a name, and I'm also going to reduce the zeros because these are the whole numbers. I'm going to do that in variable view. So first variable will be my test score. And the second variable will be my groups, the grouping variable. I'm going to reduce the decimals and then go back. So I have two variables that has names on there. And those numbers. And next I'm going to label my grouping variable. Just label the zeros and the ones. And this will also be done in variable view in values. So my zeros will be my control and my ones will be my music group. And okay, if you go back to data view, you can see that if you click on the value labels, that you can see how I labeled the values. Click on that again, so it shows the numbers. Now I've got my data ready for the test. To run the t-test, go to Analyze and go to Compare Means. Go to Independent Samples t-test. The dependent variable is the test scores, and that's the variable I'm going to test. The independent variable is a group. It's the grouping variable. I'm going to define the groups. Zeros, I'm group 1, and my ones are group 2. Continue and check on the options. 95% confidence interval, that works for me. And then OK. And I will have my output. It's here. So there are two tables. The first table shows each group has 12 students, and the control group, the average score, and standard deviation. And the means and standard deviations are for the music group. You can see that the music group on average scored 7 points higher than the control group. And we want to see that if the difference is statistically significant. So we run the t-test. The results were reported in the next table. So before check the t-test results, we need to check the Levene's test for equality of variances. Because the t-test, the assumption is the groups come from two populations that have the same variance, which is a test of the standard deviation. Basically compare these. And the Levene's test is to test the equality of variances. The noun is there is equality of variances between the populations. And the sig column, which reports the p-values, the observed p-values with a statistic. So we compare the observed p-values with the critical p-value, which is the alpha value or alpha level, that is 5% or 0.05. Since the observed p-value is greater than 0.05, we fail to reject the noun and conclude that the control and music populations have equal variances. So equal variances can be assumed, and we read off the t-values from the first row. If we cannot assume equal variances in the populations, we will read off t-values from the second row. For our data, we will read the t-values from the first row. So the control and treatment mean difference, observed difference is 7 points. And the standard error for the difference is 4.163. That is on average. If we take repeated samples of this size, on average, the difference we'll see is 4.163. We compare the mean difference against the standard error and compute a t-ratio, which is negative 1.681. As we mentioned before, that if we have an adequate sample size, that is 30 or larger, we typically compare the observed t-value with a critical t-value of 2. And this, we look at the absolute values. So if the absolute value of the t-ratio is less than 2, and we fail to reject a noun with sample size 30 or larger. And that's one approach. Another approach is we can look at the sig column, which reports the two-tailed t-test, the p-value associated with this t-ratio. And we compare this observed p-value with the critical p-value, that's 0.05. If the observed p-value is greater than 0.05, we fail to reject a noun. So in this case, we fail to reject a noun and conclude that music does not have an effect on test performance. And another way to look at to compare the means is to use the confidence interval approach. So the observed mean difference is 7 points, and we can construct a 95% confidence interval around this observed mean difference, and we get this range, which tells us that with repeated samples of this size from the two populations, we would expect the mean difference range in this interval 95% times. Since the interval includes the 0, we also know that the control mean and the treatment mean does not differ significantly. So to sum up, to find if the mean difference is significantly or not, you can compare the observed t with the critical t-value, which is usually 2. Or you can compare the sig value, that's observed p-value, with the critical p-value, which is the alpha, 0.05. Or you can look at the confidence interval to see that if that includes 0 or not, because this is the confidence interval for the mean difference. So these are the 3 ways that will tell you whether there's a statistically significant difference between means. That's the end of this tutorial. Thank you for watching.